Okay, so this is the second problem looks similar to the first, but it is different, and we need to be really careful about the description. So it says given the function f prime. So now we are looking at the graph of the derivative of some function f, and we want to answer these questions. So upon what intervals is f prime positive? Okay, notice that this does not say where is f prime increasing. It says where is f prime positive? Well, if I want to know where a function is positive, that just means where is it above the x-axis. So it is positive everywhere, here, and here. And I'm going to erase those because I'll need to draw other things on this graph. But it is positive from negative infinity to 0 and from 4 to positive infinity. Okay, and then where's the graph negative? It is negative everywhere in between 0 and 4 because it is below the x-axis, okay? And then where does f prime equal 0? Well, it equals 0 at these two ordered pairs at x equals 0 and x equals 4. Okay, I don't need to write 0, 0, and 4, 0. I can just give the x coordinates. Okay, what does this information imply about the function f? Well, if we think about the conclusions that we drew on the last video, okay, we determined that these are if and only if statements. So if f prime is positive, that means that f is increasing, and if f prime is negative, that means that f is decreasing. Okay, and I don't know if I did a good enough job highlighting this, but this stuff right here, it's very important that you memorize this relationship, because a lot of what happens in calculus is, like on AP questions, AP tests, that kind of thing, is you are given information about one piece and you are asked about something else. Like you're given information about f prime and you're asked about what that says about the behavior of f, or vice versa. Okay, so make sure that you memorize that. All right, so what does this imply about the function f? Well, if f prime is positive, that means that f is increasing on these intervals. So we can say f is increasing on negative infinity to 0 and on 4, put a comma, to 0. Don't worry about like union or comma or the word and or anything like that. It's not something I'm ever going to be picky on, but it's something that, like, there is a difference between saying or and. So I, for the most part, I generally just use commas. Okay. That's a side note there. And then f is decreasing on 0 to 4. Okay, now remember we said that this statement is not an if and only if. If f has extrema, then f prime is equal to 0. It does not say that if f prime is equal to 0, then we have an extreme, but we can still draw some conclusions by combining some things here, okay? So something is happening on the graph of f, where f prime equals 0, which is at x equals 0 and x equals 4. Okay, so let's think about this for a second. To the left of x equals 0, f prime is positive. And then to the right of x equals 0, f prime is negative. So, and normally I would be like standing in front of you doing this with my hand, but I'll just kind of trace my pen on what I would be doing. So, if f prime is positive, that means I have somewhat of a positive slope. Okay, so there's something with a positive slope. And then we hit a slope of 0. And then we hit a negative slope, okay? So we have something like this happening on the graph of f. All right, so at the point where x equals 0, where we have that horizontal tangent line, we can say, because f prime has changed from positive to 0 to negative, that we have a max. Okay, so we have a max at x equals 0. Okay, and then similarly, let's look at x equals 4. To the left of x equals 4, f prime has a negative value, which means that f has a negative slope. Okay, so f prime has a negative value, so f has a negative slope. And then at x equals 4, we have a slope of 0. Okay, and then to the right, we have a positive slope. So we are transitioning from a negative slope to a 0 slope to a positive slope, because f prime is negative 0 positive. So that means that this point right here at x equals 4 is a min. So we have a min at x equals 4. Okay. Again, just knowing that f prime equals 0 is not enough information to tell us if we have a max or a min or either, but combined with the information of what's happening to f prime around that, it is enough. All right. Okay, so then estimate f prime of -1, f prime of 2, and f prime of 4. Again, this is the graph of f prime. So what is the value of this graph at -1? F prime of -1 looks like it's somewhere right around here, something maybe not quite all the way to 3. Let's just say 2.5. Okay, so f prime of -1 is about 5/2. Your estimate can be a little bit different. That's fine. Something in between 2 and 3 is probably best, or at 3 if you want. F prime of 2 is -2. Okay, and then f prime of 4 is 0. Okay, where is f prime increasing? It is increasing on the interval. Oh, I'm sorry. Feel free to pause this whenever you want to try and answer these. So f prime is increasing from here to forever. So on the interval from 2 to infinity. When is f prime decreasing? F prime is decreasing on -infinity to 2. And where does f prime have local extrema? It has a min at x equals 2. Okay, now we're going to draw tangent lines to f prime at each of those remember that means integers. Okay, so the integral values of x over this interval. So this should look the same as your tangent line sketches on the previous one. Okay, so you should have something like that. Okay, and then it says use your tangent lines to estimate the following values. Okay, so we've got a new notation here. When we have 2 apostrophes like this, we read that as double prime. So this means f double prime of 0. Okay, so f double prime means the derivative of f prime. So f double prime is the derivative of f prime, or in other words, the slope of the tangent line on f prime. Okay, so since we're looking at the graph of f prime, f double prime is the slope of those tangent line segments that we just drew. All right. Okay, so right here, f double prime of 0 is going to be the slope of this tangent segment, which looks like it's about as steep as the one drawn over here. And remember, we estimated this one to be at 3/2, so this is probably around -3/2. Okay, so f double prime of 0 is probably around -3/2. Okay, f double prime of 2, that's happening at the min on f prime, so that is equal to 0. We have a slope of our tangent segment of 0. And f double prime of 3 is positive, not quite as steep as this one, so let's just say somewhere right around 1. Okay, about 1. And then next, looking at your tangent lines, determine the intervals where f double prime is positive, f double prime is negative, and f double prime is 0. So you can pause that and fill it in. So f double prime is positive on the interval from 2 to infinity. F double prime is negative on the interval from -infinity to 2, and f double prime is equal to 0 at x equals 0 and 4. Okay, compare the intervals to your answers to the above questions. We should have something similar to what we had on question number 1, except here we're looking at the relationship between f prime and f double prime as opposed to f and f prime. Okay, so where is f prime increasing? F prime is increasing when f double prime is positive, and then f prime is decreasing when f double prime is negative, etc. Okay, so I'm going to go ahead and write these down. So leave some space to the left of this one. Okay, so f prime is increasing, and this is if and only if again, if and only if f double prime is positive, and f prime is decreasing if and only if f double prime is negative. Okay, and I'm going to add on to onto the left side of this something about this next question. So it says, how do these characteristics relate to the concavity of the function f? So concavity is maybe a new term. Concavity has to do with the curvature. It's kind of in verbal terms, it's the rate of change of the derivative of a function, but a function is concave up if it is, think of it as cupping upwards, so like concave up, C up, cup, that's how I remember concavity. So if it is, it could be decreasing like this part over here, but it is decreasing less rapidly, or it is increasing more rapidly as we move from left to right. So something with either of these two curvatures would be a concave up interval. Okay, and then concave down, I remember concave down looks like a frown. So something this way or something this way. So it is either increasing less quickly or it is decreasing more quickly. All right, so that's concavity. So this is concave up and this one is concave down. Okay, so concavity is determined by second derivative. And we haven't graphed our second derivative on here, but I'm going to go ahead and tie these together for you. Okay, so the function f is concave up if and only if f prime is increasing and f double prime is positive. Because if a function is if a function's derivative, if f prime is increasing, then the slope is increasing. So it is getting more steep in an upward direction or less steep in a downward direction. So that would fit one of these, okay? And then vice versa for concave down. So f is concave down if and only if f prime is decreasing, if and only if f double prime is negative, okay? And then also I want to add something about what's happening when f double prime equals 0, okay? F, and this is not an if and only if statement, okay? Similar to what we wrote right here. If f has an extrema, then f prime is 0, okay? Now, whenever we change concavity, we call that an inflection point. So we can say if f has an inflection point, sometimes abbreviated IP, okay, then f double prime is equal to 0. But really, an inflection point happens, we can say, when f double prime changes sign. So negative to 0 to positive or positive to 0 to negative gives us an inflection point. Okay, so continuing this problem, it's the same one. We want to sketch a graph of f and a graph of f double prime on the same axes on the previous page or on these, okay? I'm going to start by recopying that graph of f prime on here, just so that I can see that one on top of the others. So that one is a parabola with a vertex at here, and then, so something kind of like this. Okay? And again, sorry, these aren't the smoothest curves. Okay, something like that. And let's label. We're going to have a lot of functions on the same graph here. So this is f prime. Okay, so let's do f double prime first. F double prime is going to be the graph of the derivative of this. And what do we know about f double prime? Well, we know that f double prime of 0 is about -3/2, and f double prime of 2 is 0, and f double prime of 3 is 1. So that's 3 ordered pairs on the graph of f double prime. So 0, -3/2, and 2, 0, and 3, 1. Okay, so 2, 0, and 3, 1. Okay, and we know that f double prime is negative from -infinity to 2, and then positive from 2 to infinity. So f double prime is the graph of the derivative of f prime, and it should look the same as the graph of f prime when f was a parabola on example number 1, okay? Or on problem number 1. All right, then over here we're going to sketch a graph of f. So pause it and try and look at the information that we know about f and try and graph graph the function f. Okay, we know that f is going to be concave up when f prime is positive, which is the intervals listed up here. Okay, we know that f is increasing on these intervals. We know that f is okay, so what do we know about f? We know that f is increasing on these intervals and decreasing from 0 to 4. We know that it has a max at 0 and a min at x equals 4. But here's the things that we don't know. We do not know the heights of any of those points. We know that we have, let me go back down here. We know that we have a max at 0 comma something, but we do not know how high it is, okay? And really, we don't have any information about that, so yours could look very different from mine. I'm going to put mine right here, okay? And I'll just put a little curve here to show that that's going to be a max. I also know that we have a min at x equals 4. We do not have a y value. Now, we know it has to be lower than whatever y value we picked here, okay? But we don't know how low it is, so I'm just going to pick something right here. Again, I'm just randomly, these are arbitrary selections for my points. Oops. Yours could look very different, okay? And then we know that f is increasing from negative infinity to 0, which if I go to the left here, this should, okay? So increasing along here, okay? And then it is decreasing in between x equals 0 and x equals 4, which this does increase if I draw it well enough. Okay, and then increases again. Oh, I'm sorry, did I say increase? Decrease. And then increases again. Okay, so this is an example graph of what f could look like. But the thing is that because we don't have the heights for any points, we could have another graph of f that has the same shape but takes place in a different spot. So it could be down here. Okay, or it could be way up above it. We don't really know, or it could be right through the middle. We just know that it increases, then decreases, then increases again. And we know that it has a max here, or max at x equals 0, a minimum at x equals 4, and it is concave down from negative infinity to 2, and then concave up from 2 to infinity. Okay, which kind of answers this next question. If you compare your sketches of f and f prime to someone else's, will they be exactly alike? This one should be right about the same. If your estimates were a little bit different, it might be tilted a little bit differently, like maybe you have a point a little bit higher here and then this is a little bit lower, but it should be a linear function passing through 2, 0. And then this one, we already talked about ways that it could be different. The shape could be the same, but the location vertically could be different. Okay? All right, given that f of 1 equals 5, write an equation of the tangent line to f at x equals 1. So now we have a point on the function f. Now, is 1, 5 on my graph? No, it is not. Mine's somewhere right around 1, 3, but that's okay. So this f is a little bit higher, okay? So they're telling us the point 1, 5 is on the graph of f. Now, because it is on the graph of f and has the same x value, it's going to have a slope of whatever f prime of 1 is equal to. So the slope is going to be f prime of 1, which we know because we can get that from the graph. F prime of 1 looks like it's somewhere right around negative, maybe smaller than negative 1, negative 1.5, let's say negative 3/2, which I believe is what we estimated on the first page. Or on the last page, okay? So then, given the slope and given a point, we can write the equation of a tangent line. So, y minus 5 is equal to negative 3/2 times x minus 1.